Well, yeah, thanks for coming to my talk. I'm going to be talking about the state of JavaScript security in 2025, which is actually a very exciting topic. Um, it's something that we all interact with every day when we're writing code as JavaScript developers. Thinking about security, really important. Not something that you know um, necessarily always feels like the most fun topic, but I'm going to do my best today to make it fun and exciting. And I think there is actually quite a lot of exciting stuff in this talk. So thanks for coming. Um, to get started, I just wanted to share a little about who I am. So I'm Feross. I started out in open source, kind of been doing it for about 10 years. I wrote a bunch of open source packages in NPM. The software that I wrote gets, I don't know, a billion plus downloads. It's actually kind of scary sometimes when I think about how much, how bad it would be if my NPM account was compromised. Speaking of security, um, I spent most of my time working on two projects, WebTorrent and StandardJS. Both both were super fun and occupied a whole bunch of my kind of 20s and kind of is were how I got into open source. Then I kind of moved into security and focused on different things in web security. I taught a course at Stanford. And now I'm working on the combination of those two areas, so open source and security at Socket, where I'm the founder and the CEO. I'll just do like a quick thing on like what Socket is, and then we'll kind of get into the talk. So Socket is a tool that helps you protect your code from everyone else's code. And I built it. I kind of started the company, and now there's a whole team of people, and we're building Socket because we want to help developers and security teams to basically kind of ship faster and spend less time on security busy work, so that they kind of help help them to safely find and audit and manage their open source dependencies. So we do the kind of typical stuff you've probably seen with some of these tools where we can help you find out if the dependencies you're using have vulnerabilities. But more than that, the exciting part is that we do this like really deep dependency analysis, and we look at a whole bunch of other things that go beyond just like, hey, is there a vulnerability in this package? I'm going to get into kind of some of those things in this talk, but what you'll end up taking away from this, hopefully, is that there's so many more things to care about when you think about, is a dependency something that I should use in my project or at my company, than just is there a vulnerability in it? I mean, as developers, we know we care about a lot of other things, like, for example, is it maintained? Does it have documentation, right? Does it have a lot of downloads and support and a community, right? Does it have, is it is it deprecated, for example? That would be really bad. Don't want to be introducing new dependencies that are deprecated. So things like that, kind of, it's really a more holistic way of looking at, the open source software that makes up all of our applications. I'll just end like kind of last thing is just some of our customers. We really since we've been working on this for the last I'd say 3 years, we've been kind of able to protect uh, almost it's getting close to 10,000 organizations now that are using Socket, and close to 500,000 actually repositories that are being scanned by our tool. So it's very awesome to see kind of how quickly people have recognized kind of just the importance of like caring about your dependencies. But yeah, and with that, I'll jump into the actual kind of meat of the talk now. So kind of to start off with, like, why is JavaScript security hard? So I think kind of the thing that the quote that I think makes this the clearest is this quote from this old web security book called Tangled Web that I really love. So the quote is, modern web applications are built on a tangle of technologies that have been developed over time and then haphazardly pieced together. And if you know anything about web development, this should feel very this should really resonate with you, because the web is really this patchwork that's been developed over the course of 25 plus years, and it really is a bunch of random um, different standards that have all been kind of cobbled together into this beautiful thing that we love called the web. Um, so if you think about what the browser has to do, it's actually quite quite an impossible, seemingly impossible task, right? So websites, even malicious ones, can download and execute code from anywhere. They can spawn worker processes, open sockets, to servers or to other users' browsers. They can display media, video, audio in a number of different formats. They can run code on your GPU, and they can access your file system. So, and then there's a combinatorial explosion of different ways that these APIs can be used together. So, how do we make this all safe? If you think about it, just it's actually crazy that this works. And yet, it does work, right? So the web is robust. It's and this is another quote just here from Ilya Grigorik, another person I look up to. So he says, it's all too easy to criticize, lament, and create paranoid scenarios about the unsound security foundations of the web. But the truth is, all that criticism is true, and yet the web has proven to be an incredibly robust platform. So that's kind of the one, kind of the first area I'd say. Why is security hard? It's because we're building on this foundation that's so haphazard and has a lot of moving parts. But I'll ask it again. So why is JavaScript security hard? There's many reasons. Another reason is that NPM is actually kind of part of the problem here, but it's because it solved a really hard problem called dependency hell, and it solved it so well that it really kind of created a problem for all of us, a security problem, which is that you've probably seen this image before. Everyone likes to use it in their talks of kind of how node modules is kind of this huge folder. No one knows what's in there. It's just a ton of files, and there's tens of thousands of dependencies in any given app. And that is true. That is definitely true. Although, as we'll see here, it's actually not entirely for kind of bad reasons why this is the situation that we have that we live with. But before I kind of get into that, I want to just make sure everyone knows what we're talking about when we talk about kind of transitive dependencies. So what you're looking at here is a picture of kind of how dependencies work. And there's kind of two types of dependencies: direct dependencies and transitive dependencies. So direct dependency is when you say, I need to use this package to make my package work or to make my application work. And then a transitive dependency is a dependency that one of your direct dependencies directly depends on. So it's sort of like if you go two levels down, then we call that a transitive dependency. And this is really where all of the kind of packages in your node modules folder come in. It's almost all transitive dependencies. And as we'll see, it's sort of very quickly becomes this huge pile of dependencies. So what I want to talk about is kind of this definition of dependency hell, because I think it is a really interesting point. And that is that, we think of this sort of crazy pile of dependencies often as dependency hell. That's what people say today. But in reality, the kind of original definition was very different. And it was about when you get your application into a state where you can't install your application because you've depended on kind of a set of dependencies that cannot be installed by the package manager. So in this example here, you can see that my app, depends on foo client and bar client, and each of those depends on requests, but different versions of requests. One of them needs 2.3, one needs 2.5. So what happened before NPM existed was package managers would just throw up their hands and say, I can't install this. I can't install two different versions of the same package. And so it created this really terrible situation for developers where they couldn't really proceed, and they kind of got into a situation where they're like, what am I supposed to do here? Because these aren't even dependencies that they're aware of, that they control. They're transitive. They're not even kind of the ones that they've directly decided to use. And so NPM came along and just said, hey, let's just install all these dependencies. Like, it doesn't matter if there's different versions, we'll just install all of them. And then when foo client asks for requests, we'll give it the version it wants. And when bar client asks for requests, it'll get the version it needs. And just like that, we kind of solved this problem. But what that kind of did, and it was the unintended kind of consequence, was it led to basically this sort of state where we were in now, where applications now can depend on thousands of dependencies, because no longer can you get yourself into the situation where you can't install and kind of proceed in your application. So today it's super common to see apps where 90% of the code comes from open source dependencies, and we have tens of thousands of dependencies. This visualization here is actually showing you just one single dependency, Express, and every gray box is a package and every purple box is a file. And kind of what you see here, if I restart it for you, is you can see as you open up the package, you see within how many packages there are and how many additional files there are, and then you can kind of keep peeling them back and seeing just how deep this this rabbit hole goes. Here's another visualization showing kind of create React app and the dependencies that it brings in. And what's wild is the average package brings in 79 transitive dependencies. So there's just a lot of dependencies that you don't even know you're using. Um, the average GitHub repo has about 683 transitive dependencies. And what I want you to notice here is look at the number that are in JavaScript. It's really quite a lot. It's very different than other ecosystems. It really stands out. Um, so now kind of what are the consequences of this? Well, kind of the big one is that this creates a situation where now attackers can attack any of these dependencies and get into your application through your dependencies. And because there's so many more dependencies, it's so much easier to find one weak link in the chain and get into your application. And these are some of the kind of recent headlines around different kind of attacks against NPM. So this is a really big, I'd say the second kind of big reason why security is hard in JavaScript. And then kind of the third reason is that the top 10 web vulnerabilities are always changing. So we see really a lot of just different techniques that are always developing and what I like to look at is the OWASP top 10. This is a set of kind of 10 top vulnerabilities that are put together by this security organization that does really good work on web security. And just a few things to note here. So broken access control is now the number one kind of security threat in 2021, which is the last time they put this together. And it moved up from the 5th position. And then also cryptographic failures is number 2, which used to be known as sensitive data exposure. And that's really focused on like any way that you might expose data, whether it's a cryptographic failure or some type of bug in your application. And then injection is interesting. So injection used to be number 1, but it's now gone down to number 3 thanks to frameworks like React and Vue and other things where they basically handle cross-site scripting for you and kind of prevent you from creating XSS vulnerabilities in your application. And then another interesting point is that vulnerable and outdated software components, which is you can see here is number 6, has increased from the 9th spot up to the 6th spot. And it covers supply chain attacks as well as vulnerabilities. So this problem I've been talking about around too many dependencies creating risks, this is very much now a growing threat that we're seeing just increasing really quickly. So I'm going to spend just a kind of couple minutes talking about some of the interesting ones within this, but I don't want to spend too much time because I want to get to kind of the interesting stuff I have at the end. But let's talk about just a few of these. So we have broken access control. This is things like really exposing sensitive data in a way that you might not be checking it on the back end, but you might have like a link or UI element that you hide for certain users, but actually the back end allows those requests to go through even to the wrong kind of wrong people. There's kind of direct object references where you're manually changing URLs and finding data that you're not supposed to find, and the server not really validating ownership correctly. And there's really a whole bunch more here: API problems, privilege escalation, problems with your cookies or your JWTs, and then of course CORS. A lot of us will just often Google how to fix CORS problems and end up kind of creating really bad configurations on our sites. So kind of some tips here to fix these. Always kind of deny by default. Implement access control mechanisms once and reuse them throughout your application so you're not constantly littering this code everywhere. Make sure you do basic things like not serving up your web server directories and your .git folders and things like that. You should have logs. Make sure people can't repeatedly log in and try it a million times and finally get in. Rate limit your APIs and things like that. So now I'll talk about kind of cryptographic failures. This one is basically just making sure that you're not basically you're using HTTPS and you're not transmitting data in the clear. Making sure you're not using old cryptographic algorithms. Making sure that kind of you're not checking in your keys or your API keys into your source control and leaking them that way. And then making sure you're kind of using randomness that is actually cryptographically safe. So don't use math.random. Math.random is not to be used for anything sensitive. and don't use kind of old hash functions like MD5 or SHA-1 and anything that's security sensitive. And there's some advice here. You can turn on kind of HTTP strict transport security. You can kind of encrypt data at rest, and hire a pen tester to really try to break your application. That's probably the best piece of advice on this entire slide, is just make sure that you're really trying to break your application by hiring a professional to do that for you. This is one that I think I mentioned before, injection, which is actually improved quite a lot because of frameworks. But in React, if you ever use dangerously set inner HTML, that's something that's clearly unsafe, and you can kind of see that in the name of the method because it has the word dangerous in there. In older templating libraries like Pug, you often just see that the hash is used in a safe way, and then the exclamation point means that the variable will not be escaped. The HTML will not be encoded properly in the page, and that creates a security risk. But you can't really tell by looking at that exclamation point that that's really dangerous. And so one of the things I really think is important is that frameworks should do the right thing by default, and they should make it hard to do unsafe things. They should make it clear that when something is unsafe. So React takes the cake here over Pug for sure in terms of making it clear when something is unsafe. One of the things I actually think is kind of funny is in an older version of React, they used to have this variable that was exposed in the window that was called secret DOM do not use or you will be fired. And again, in the spirit of kind of naming things in a way that will make it clear when things should not be used, I think this actually does a pretty good job, even though it was somewhat controversial that they named it this. And then kind of insecure design is number 4, and this is one that I'm going to mention just because I think if you screw up at the design stage, it doesn't really matter if you have bugs in your implementation, or even if your implementation is perfect, because the design is broken, right? So a secure design can have defects leading to vulnerabilities, but if you have an insecure design from the beginning, then that cannot be fixed even by a perfect implementation. So you need to kind of make sure the whole design really makes sense from the beginning of your project. And so the way to do this is something called shift left, which just really means thinking of security from the very beginning of a project. And a great way to do this is to use security tools, linters, kind of static analysis tools to look for problems in your code. Shout out to the project I worked on, StandardJS, which actually looks for severe kind of security bugs and issues in your code. And kind of integrating that data into the developer workflow so that there's a feedback loop, so that you can kind of learn when things are messed up or broken from the earliest point in the project. And then it's really important that as we kind of think about like the developer experience of our tools, that we're making it easy for developers to do the right thing, and they're not having to kind of go out of their way to do things in the secure way. The secure way should be the default. And kind of to that end, right, security tools shouldn't really block developers. They should empower developers to be self-sufficient. So the tools should just work out of the box. They should do the right thing, and they shouldn't really ask a lot of the developer or stop them from being productive. They should help the developer to do their job better. And so this is kind of one of the things we take to heart in the way we built Socket. So, another shout out if you're looking for kind of a security tool to bring into your company, and it's one of the things your boss has asked you to look at, I definitely recommend taking a look at Socket because it's been built in a way that really does help developers do their job better and kind of stays out of the way otherwise, and doesn't slow you down. And now I'll bring us to kind of the last one that I want to cover, which is vulnerable and outdated components. And this is really about this idea of the software supply chain, or kind of the collection of all of the dependencies that we use in our applications. And when we think about flaws in our dependencies, there's really 2 categories that we think about. One is accidental, like bugs, coding errors, right? And the other is intentional bugs. So like think of backdoors or intentional like viruses or malware that have been put into your open source dependencies. And you're likely vulnerable to these types of attacks if you don't know kind of the set of all dependencies that you use, or if you're using vulnerable, unsupported, or out-of-date software. And if you're not scanning for these things, then you're almost certainly vulnerable. And finally, if you're not really upgrading your dependencies on a regular cadence, then you're also probably vulnerable. So how do you prevent getting kind of attacked through this mechanism? Really, I look at it as kind of a whole kind of a way of thinking about the problem. So first of all, you want to understand what open source you're using. So you need an inventory of what open source you're using. Once you have that, you can understand the threats that your company or your project is going to be exposed to. Then once you have that list, you can scan it to look for vulnerable or malicious components that are in that list. And then you can try to go and fix those by changing what dependency you're using, upgrading them, et cetera, et cetera. And then you want to kind of enforce some type of a policy throughout the whole software development lifecycle, such that, you know, whenever you're bringing in new dependencies, you're not having to remember to check all the security things you care about, but it's actually kind of automatically enforced proactively so that you're not going to be affected. Even if you forget to check all the things you're supposed to check. So I know that this idea of software supply chain security can be abstract, so I want to kind of make it concrete and really show everybody an example. So this is an example of what a supply chain attack actually looks like. This is a real example. This is something Socket detected. And what's going on here is, I'll make it really clear for you here by highlighting a few of the lines of code here. And what I want you to notice is, first of all, this is code that was added into a dependency. And you can see it's requiring HTTPS, so it's going to make network requests. And then it's using process.env, which if you are familiar with Node, you know that this gives you access to all of the environment variables. And this is where the secrets, the tokens, and the keys that might be in your environment, in your terminal, where they live. They live in the environment variables. And then it's taking that and sending it in an HTTP request off to an attacker. And it's actually obfuscated the domain name here, so it looks like it's an array, but it's actually, in the end, is going to become a domain name that the request goes to. That will then kind of basically steal this information, steal your API keys and your secrets and your tokens from your environment. So this is the kind of thing that leads directly to a breach or a compromise of the software product. And so the core problem, if you really think about it, is that developers can't kind of really be expected to read every line of code in their dependencies. There's just too many like dependencies. There's too much code changing all the time, too many updates, too much stuff going on. And so just to kind of illustrate this for you, I want to show you just a few of malicious packages that Socket has published, or sorry, not published, Socket has detected that were published recently. So I'm going to start from kind of the simplest ones and get into the more kind of crazy ones as we go. But so this is an example of a malicious package that we detected, and it's just blatant in what it's doing here. So I'll highlight some things here to show you the key points. But it's using curl to basically steal your /etc/password file, which is kind of a file that contains a list of all of the usernames and hashed passwords on your system. And it's sending it off to this ngrok URL right here. So this is just blatant, like it's just stealing your data off of your computer if you run the package. And so our system was able to actually automatically detect this as malicious, and it has this explanation that's written by an LLM using the latest GPT models from OpenAI, and it says the code is intentionally designed to perform unauthorized data exfiltration of sensitive system information. So very clearly detecting what this code is doing. So it's pretty cool that we're able to kind of use AI in this way to help us look for these threats, even though it's really an intractable problem if you were to rely on humans to do it, just because there's so much code out there and so many dependencies. Now it's usually not that simple. Usually the attackers try to hide what they're doing a little bit more than than that last example. And so this is something we see quite a lot. This is an obfuscated file, and what they've done here is they've used a tool to not just to minify the code, but to actually go further than that and obfuscate it. So you'll see a lot of like parse int and things like that in this code, and what that's doing is really hiding the fact that what this code is. It's really just turning it into a bunch of kind of hex values that call different functions that all have hex names, and then it kind of all turns into the kind of final code when it runs. But it's very hard for a system looking at this to figure out what it's doing, or a human for that matter. And so what I'm going to draw your attention to, though, is even these tools, they're not perfect. And so they left a few strings and a few function names in here that we're able to look at and able to kind of use to figure out what this code might be doing. And so download exe doesn't sound like a very good function to me. It sounds like it's going to be downloading a sketchy file onto your computer and running it. And if you scroll down here, we also find some other interesting, suspicious strings in the code, including Discord app .com, as well as an exe file name, as well as kind of things like child process, which is used in Node.js to spawn new processes, things like that. And so our system was able, again, to detect that this was bad, that it's doing arbitrary code execution, it's downloading files from untrusted sources, and it's putting files into the node modules folder in a weird way. So obfuscation can help attackers, but it's often not good enough, and we're able to still kind of detect these things with our system. And then I kind of want to show you this last example because it's really wild. This is a pretty deep level of obfuscation that I'd never really encountered until recently. But this is more than just using a tool to kind of generate this unreadable code. It's actually hiding its behavior in a really kind of tricky way here. So let me walk you through it. So the first thing you'll notice is it's calling this type function, and then it's using the return value in this to get data off this HTTP object. And if we go up and look at what the type function is doing, you'll see that it returns, it loops over this this array of 0, 1, and 2, and it calls prop getter, passing in the number. So what does prop getter do? Prop getter calls prop value, and it passes in prop getter. So this function is passing itself into as the first argument to prop value, and then it's passing in the number 0 that was passed in as an argument. Okay, so that's weird. Now, finally, then what it does is if you go to prop value is looking at this function, and you'll notice it has these weird comments. So prop getter has this like 3 lines here: number 1 West, number 2 question, number 3 Ireland. And what it's doing is it's taking the function prop getter, turning it into a string, and then looking at each line, and it's basically looking for the comments. And then it kind of slices off just these words out of the comment lines, and then it uses these indexes here to basically slice out specific parts of these words. So it's looking at the 2nd to the 4th letter of West, which is ST. And then it's looking at the 0 to 3rd letter of question and the 1st to 3rd in Ireland, which is RE. And then if you notice, what does that make? Well, it's reverse. First of all, it reverses them. So if you reverse these, what do you get? You get REQUEST, which spells request. So all of this work is basically all this code is just producing the string request at the end of the day. And so what you see here is it's really just putting in requests there. And all of this was designed to get around some security tool that was looking for http.request. And so, they tried really hard to hide the fact that they were making an HTTP request. But again, our system was able to detect this. LLMs are really powerful, especially when you kind of combine it with static analysis in the way that we've done. And so we're able to kind of find that this is sending environment variables, it's obfuscating, it's obfuscating the prop value function, and then it's basically using that to steal data off of your laptop or your production system. So it's kind of wild to me the lengths to which these attackers are going. And I know as developers we don't often think about these things, but this is the kind of stuff that could be in your dependency tree if you're not careful. And so it's important to at least know, that this stuff is out there, and you got to be careful and think carefully before you bring in dependencies. But sometimes it's not even in our control. Sometimes an existing package that we're using has this kind of code added to it. And so kind of one story I want to tell quickly here is this is actually a cool story because it's the thing that inspired me to start Socket. This was a package that was compromised back in 2017, or maybe actually even earlier than that. I think it was 2015. Actually, maybe I'm trying to remember. I think it was 2017 actually. So what happened was this prolific maintainer named Dominic Tarr, really old school NPM maintainer, made a ton of packages, was really instrumental to kind of Node's early success. So he had a package that he really wasn't maintaining very much, and he stopped working on it in 2015. And you can see here that this comment thread shows he kind of really wasn't maintaining it anymore. Somebody emailed him and just said, "Hey, can I help you maintain this? I'm using this package and I'd love to be able to help improve it and merge PRs and kind of make sure that it gets the love and attention that it needs." And so Dominic just transferred control over to this guy. And then uh, he did good work for about a month on the package. And then after about a month, here's what happened. So there was someone who noticed that now when you use the package, a deprecation warning gets printed out in Node at the very beginning of Node starting up, which wasn't there before. And it it was eventually kind of traced back to this function that was added into event stream. So the kind of new maintainer added in this crypto.createDecipher function, and this turns out that it was deprecated in Node 10 just a couple days after the new maintainer had kind of published a new version. So the new maintainer probably didn't know that this was going to get deprecated, and so turns out like okay, now it's deprecated. So at first this issue didn't look that weird. It's just like okay, it's a deprecation warning. We should go and fix it. But the community kind of got a little bit suspicious about this widely used package with millions of downloads being taken over by a new maintainer. And so a few folks did a little bit of digging and learned that the new version that has this function in it, this deprecated function, it added in this code here that you can see in this minified file. And when you unminify it, you actually get this function here. And this looks really, really suspicious. I want you to notice a few things here. So number one, there's a bunch of encrypted data that's in this array here, and then it gets decrypted using process.env.npm package description. So what does that mean? That means that it's looking at the npm package.json description field. This is something that gets loaded into the environment automatically by npm when you use npm run to run scripts. And so that description field, it's usually just a string that describes what your application does, but it's being used by this code as a decryption key to decrypt this string and then to execute it. That is very weird. And so it turns out what it was doing was it was targeting this one application called Copay. And Copay has the description field of a secure Bitcoin wallet. So that's the string. So it turns out that's the string that you needed to pass in to get that code to successfully decrypt and to run. So that means that anyone else using this code that was not, building this Copay application or working on Copay, it would fail to decrypt and it wouldn't affect you in any way. But if you were unlucky and you're working on this specific project, it would run. And that's basically kind of what the attacker was trying to do, was to basically get this into this specific wallet, Bitcoin wallet. And they stole a bunch of cryptocurrency. This actually got built into the final Electron app that was shipped to users that used this app on their systems, and it stole all their money, all their cryptocurrencies. And this is kind of the aftermath. So people were asking Dominic, like, hey, why did you give your module to this new guy who didn't have any track record? And Dominic said, well, the guy emailed me and he said he wanted to maintain the module, so I gave it to him, and I don't really get anything from maintaining this. I don't even use it anymore, and I haven't for years. And I'm not even a publisher anymore. I gave it to this other guy, so it's really not my problem anymore. And that's actually the attitude of a lot of maintainers when somebody comes along to help them, is like, well, if they're not really getting anything from it anymore and someone else wants to do the work, then that's really how open source works. There's nothing really that weird about this. This is common. People share maintainership and add new maintainers all the time in open source. So anyway, this is just, I think this was a crazy story because basically it was caught by an accident. Really, this deprecation warning was the way that we discovered this happened. If there hadn't been a new version of Node that came out just a couple of days after the attack went in, we probably wouldn't have discovered this for a very long time. And that scares me. That scares me because it means that malicious packages are really taking way too long for the open source community to find today. It's taking over 200 days right now for people to find these packages and to get them removed. And 20% of them last over 400 days. So that's over a year that these are just sitting on NPM, and they might affect anyone who's unlucky enough to install it. And that's really not okay, in my opinion. So again, this is why we built Socket. Like we built this whole system to try to scan and look for these things. We're finding hundreds of these every week. We have our tool kind of works in Java, Python, Go, Ruby, NPM, of course. And whenever we find a malicious package, we report it and we get it taken down to protect the whole community. And then we also obviously um, protect our customers as well. Um, and unfortunately, these ecosystems don't all necessarily do the best job to get these things taken down quickly when we report them. And so in some cases, these things remain live even for weeks or months, and sometimes years, unfortunately, and never get taken down, even after we report them. So, a tool like Socket is unfortunately kind of feels kind of necessary until these registries start to kind of improve the speed at which they process these kind of security notices that we're sending them, right? So I'll add a kind of a fourth reason here, which is why security is hard in JavaScript, which is that when you have this many dependencies, there's really this massive kind of flood of alerts and noise that we're looking at. And so while these malicious attacks that we've been talking about are pretty rare, um, vulnerabilities are very, very, very numerous, and developers and security teams are really just drowning in these alerts. If you've ever used npm audit or done an npm install, you'll see this little thing that says 100 vulnerabilities, and almost all of us just ignore this because it's like, what am I going to do about this? There's really not much I can do. In fact, Dan Abramov even called npm audit a stain on the entire npm ecosystem because of the way that it works is so broken. It just constantly complains that things are vulnerable and there's really not much you can do. And that's a great way to basically create alert fatigue, and ultimately alert blindness for developers. So if I had to sum up kind of the problem with these types of vulnerability scanners like npm audit, I'd say that it's basically that they send too many alerts. Most of them are false positives, in the sense that technically there might be a vulnerability in that code, but it's not the case that it's actually necessarily used in your application. For instance, the vulnerable function might not actually be called by your application. And so these tools are really reporting unreachable vulnerabilities, vulnerable code which never runs. That's a really big problem, as well as developer dependencies and severities that are really inflated. You get a lot of criticals that really should be mediums or lows, in my opinion. So there are too many alerts. But then on the flip side, they're also sending not enough alerts, I believe. So they're not sending the right alerts. So the things that we really care about, the worst attacks, are some of the things we've been talking about in this talk so far. Things like supply chain attacks, malicious dependencies, typo squats, right? Backdoors, hijack dependencies, hidden behavior that's been added into packages. These are the things that actually will immediately affect you, and that there's really no way to detect today. And so and these tools don't help us with this really hard problem, right? So that the full picture of open source risk is vast. There's not just vulnerabilities. There's things like quality issues. There's maintenance risks. There's a whole bunch of supply chain risks. I've talked about a few of them so far, but there's a whole bunch of other ones here on this page. More than I can get into in this talk. And then there's license risks as well, legal risks for using code. And so this is really the way I would think about it. It's much more expansive than just vulnerabilities, and yet npm audit really just focuses on just vulnerabilities. Other popular tools like Sneak here, they just focus on vulns as well, and there were instances of malicious code that they were reporting as safe because there wasn't a vulnerability filed for these, even though the code was malicious. So malicious code is unfortunately not part of the vulnerability system, and so you really need something like Socket or a human looking at this code to find out if the code is safe. You can't rely just on something like Dependabot, or anything like that. I think the DX is really important. npm audit is just too noisy, too unusable, and really just doesn't tell us about the things that are important. And this is true of a lot of security tools. So let's see here. Coming up on time, so I will cover kind of maybe one last reason why security is hard in JavaScript, and that is AI threats. There's new threats coming from AI. So we have a lot of good things that have improved in JavaScript, but AI is a really big change. So one big reason is that AI models are actually executable code. They're not necessarily just data. And so what that means is that when we bring in AI models into our applications, we need to treat them as dependencies. They're code that runs on our system. They're not just, like the equivalent of a JSON file or something like that. We've seen many cases where AI models have backdoors in them and similar attacks like we've covered in this talk. And so one of the things we're starting to do now is we're scanning models and most of these live on Python on PyPy because Python is what a lot of the AI development where that takes place. So we're scanning pickle files, which is the kind of data interchange format that's used in Python that you might be familiar with. Pickle is unlike JSON. Pickle files can contain executable code, and so that's kind of the vector of attack here. Is that it's these serialized objects that can contain executable code that everyone's passing around and treating as data when it's really potentially code. So I'll leave it at that. I don't want to get too much more into this, but I'll just leave you with a couple pieces of kind of parting wisdom. And that is kind of to start with, just think about security early in your design. The earlier you can think about security, the safer you'll be. The cheaper it is to fix the problems, less time it takes, the less painful it is. Use frameworks and libraries for security sensitive things like auth, crypto, escaping things. Study the OWASP top 10. Make sure you understand what the top 10 web vulnerabilities are. Make sure that you're, not introducing those types of things into your apps. And then understand your open source dependencies. Make sure that you're scanning them with a modern security tool. And a pro tip is Socket's free. So I have to mention that if you are using us for open source or you're on a small team, you can get started with it in a couple clicks and add it to your GitHub, and it'll start providing kind of feedback on your PRs right away. And then the final thing is that make sure that as you kind of start to look into different kind of ways to prevent these problems, that you choose security tools that are optimizing for a good developer experience. It's important that we don't burn kind of goodwill with developers by bringing in noisy tools or things that really slow people down and kind of create pushback to this desire to improve security. So that's pretty much my best advice. Hopefully this talk has been helpful and useful. Thank you for taking the time and spending the past 45 minutes or so with me. And stay secure out there. If you have any questions for me or you're interested in any of the stuff we talked about here, you can send me an email. It's Feross@Socket.dev. You can also check out my GitHub or my Twitter. I'm happy to talk about any of these topics or Socket or open source dependencies or anything like that if anyone's interested. Yeah, thank you for your time. I appreciate it.